By every rule of aviation, a jet this size shouldn't exist. Yet Airbus not only got it airborne, they built an aircraft so massive it forced airports and engineers to rethink everything. Where Boeing was chasing composites and fuel savings, Airbus chased scale, but at what cost? The gamble reached $25 billion, and it nearly broke the company. Today we'll reveal 10 engineering marvels of the A380, the breakthroughs that made the impossible possible and the problems this giant had no right to solve. 1. The double-deck cabin. For decades, the dream of a true double-deck airliner haunted aircraft designers. Boeing considered it with the 747, but abandoned the idea, fearing evacuation times and structural collapse. Airbus decided to push through. The challenge was staggering. How do you pressurize and reinforce two passenger floors stretching 240 feet without the weight becoming unmanageable? The solution was an oval fuselage frame, strengthened with carbon fiber reinforced plastic in critical joints. Engineers even had to redesign emergency slide systems, ensuring 800 people could evacuate in 90 seconds from two decks without bottlenecking. The payoff was floor space unmatched by any jet in history, over 550 square meters. Airlines suddenly had room for onboard bars, lounges, even showers. For the first time, passengers could walk up a staircase in the middle of a flight, not into a cockpit, but into another world, an upper deck filled with travelers cruising across oceans. 2. Wings wider than a football field. The A380's wingspan measures 79.75 meters, wider than an NFL field. That kind of span should have made the aircraft impossible to control, too heavy to lift, or too unwieldy for most airports. Airbus engineers responded with wings that flex in flight by almost 5 meters at the tips. The flex absorbs turbulence, reduces drag, and spreads enormous loads across the structure. The wings also hide a secret: built-in fuel tanks capable of holding over 320,000 liters, enough for flights from Dubai to Los Angeles. But there was a catch. Most airports weren't built for wings this wide. Taxiways and gates had to be expanded into a new international standard just to accommodate the A380. In flight, though, these wings make the impossible look ordinary. 500,000 kilos of aircraft lifting smoothly, with the grace of something far smaller. 3. Engines for a flying city. Now moving a jet this massive required an engine that didn't exist. Airbus partnered with two teams. Rolls-Royce built the Trent 900, while General Electric and Pratt & Whitney joined forces to create the GP7-200. Each engine produced up to 80,000 pounds of thrust, power on the scale of nuclear submarines. But could an engine this big really stay quiet enough to land at downtown airports? That was the gamble Airbus had to win. These engines also had to meet strict noise limits, sip fuel as efficiently as possible, and run for thousands of hours without failure. Engineers used advanced fan blade aerodynamics and heat-resistant alloys to push the limits of turbofan technology. The result was an engine that could lift over 500 passengers and their luggage across oceans quietly enough to land at city airports. 4. A landing gear to carry 575 tons. Landing a fully loaded A380 means bringing down 575 tons onto a strip of asphalt. No conventional landing gear could spread that weight without tearing runways apart. Airbus's solution was one of the most complex systems ever fitted to a jet. 22 wheels spread across 5 separate assemblies. Each bogie pivots and tilts, distributing pressure evenly. In fact, despite its size, the A380 exerts no more ground pressure per wheel than a smaller Boeing 777. Designing it wasn't simple. Hydraulics had to synchronize dozens of struts, tires, and actuators perfectly. A single fault could mean disaster. Watching the landing gear deploy looks like a machine unfolding in stages, each piece locking into place with precision. And when the wheels finally touch down, the giant's weight settles gracefully, as if a 575-ton aircraft weighing more than a skyscraper was nothing extraordinary at all. 5. A tail taller than buildings. The A380's vertical stabilizer towers 24 meters, taller than a 7-story building. Its job is to keep the jet stable in crosswinds and during turns, but scaling up a tail this large created new problems. Turbulence at the base risked shaking the fuselage, and the weight could have acted like a lever, snapping the structure in two. Airbus solved this with composites and titanium reinforcements that added strength without piling on extra mass. The tail also had to house one of the largest rudders ever built, powerful enough to correct the yaw of an aircraft longer than 2 blue whales nose to tail. On the ground, it looks absurd, a wall of aerodynamics towering above everything else on the ramp. But in flight, passengers rarely notice. The tail works silently, holding steady the largest passenger jet in history against crosswinds that would rattle smaller planes. 6. The world's largest pressurized cabin. Pressurizing a cabin this size was unlike anything attempted before. The A380's double-deck fuselage created a massive internal volume that had to be evenly balanced to avoid structural failure. Airbus designed reinforced fuselage barrels with composite panels that could withstand immense stress. The air conditioning system pumps nearly 2 million litres of air every hour. One wrong calculation and the pressure difference could tear the aircraft apart mid-flight. So how do you build a cabin for 800 people that still survives at 40,000 feet? Engineers tackled not just strength, but evacuation. Everyone had to get out in under 90 seconds. The answer was new slide systems and redundant exits. For passengers, the results were invisible. A cabin so well insulated and quiet, you could talk in a normal voice, even near the engines. What might have been a pressurized steel drum instead became one of the most spacious and comfortable environments in the sky. 7. 500,000 kilometers of wiring. Looking inside, the A380 runs over 500 kilometers of wiring, enough to stretch from Paris to Brussels and back. Those wires power everything from flight controls to entertainment screens. The challenge was not just the volume, but the routing. Bundling so many wires through a double-deck fuselage required millimeter precision. Early in development, Airbus faced major delays when digital design software from different facilities didn't align, leaving gaps in the wiring plans. Fixing the error meant reworking thousands of connections. Once solved, though, the system could handle the demands of a flying hotel. Hundreds of individual screens, lights, galleys, and safety systems operating without fail. To passengers, this complexity was invisible. But every time they dimmed a reading light, adjusted their seat, or watched a movie at 40,000 feet, it was made possible by one of the densest electrical systems ever put in the air. 8. Cockpit of a giant. Now step into the A380 cockpit, and you'd expect something intimidating. Yokes the size of car wheels, banks of analog dials. Instead, pilots found familiarity. Airbus designed the A380's flight deck to look and feel like other Airbus jets, from the A320 to the A340. Side sticks replaced yokes, while a fly-by-wire system translated digital inputs into precise control of surfaces. The real marvel was how normal it felt to fly. Despite commanding the largest airliner ever, pilots reported that it handled with the grace of smaller jets thanks to computers smoothing out the physics behind the scenes. Common cockpit layouts meant crews could transition between Airbus aircraft with minimal training. 9. Airports reshaped by a plane. This might come as shocking, but the A380 forced airports worldwide to evolve. Standard runways, taxiways, and gates couldn't handle it. So the International Civil Aviation Organization created a new classification, Code F. Major hubs like Heathrow, JFK, and Singapore Changi invested billions to widen taxiways, reinforce bridges, and build double-deck jet bridges. Boarding now happened on 2 levels at once, a first in commercial aviation. Even airport firefighting systems had to be upgraded to handle an emergency involving 800 passengers. For airports, welcoming the A380 was a symbol of status, proof they belonged in the top tier of global aviation. For passengers, the changes were visible from the start. Boarding an aircraft directly onto an upper deck felt futuristic. Rarely had a single plane reshaped the infrastructure of an entire industry. 10. Comfort on an unmatched scale. The A380's true marvel was the passenger experience. With 50% more floor space than the 747, airlines could design cabins that felt less like airplanes and more like moving resorts. Emirates fitted onboard bars and showers. Singapore Airlines introduced suites with sliding doors and double beds. Even in economy, the wider fuselage meant more elbow room, quieter flights, and gentler takeoffs and landings. Part of this comfort came from design. The engines mounted farther from the cabin reduced vibration, while the double-deck layout spread passengers across more space. For travelers, it was surreal, stepping inside a machine so huge yet finding it quieter and more spacious than smaller jets. It was the one area where engineering and passenger dreams aligned perfectly. The A380 may not have conquered airline economics, but it redefined what flying could feel like. For millions, the best flight they ever had was on this giant. When the Airbus A380 first lifted into the sky, it showed the world that aviation's moonshots were still possible. It may never have ruled the skies the way Airbus dreamed, but for millions of passengers, the memory of climbing its staircase, walking its wide aisles, or hearing the hush of its engines at 40,000 feet is unforgettable. So tell me, did you ever fly on the A380? Was it the space, the silence, or the sheer scale that stayed with you? Share your story in the comments. And if you want more journeys like this, make sure you're subscribed. We'll be back soon with more stories from the skies.